It's called the continuously compounded rates. Let's make this insanely high. That's pretty much it. There's a different way of calculating it too, but let's stick with our two. Okay. So if you have two bonds that has exactly the same yield to maturity, but one is quarterly compounding, the other semi-annual, the semi-annual compounding one is going to have a lower effective annual rate compared to quarterly, which means the bond that compounds quarterly is going to be worth a little bit less because you're compounding technically at a higher rate. Let me change that into something like that. All right. One thing we need to worry about bonds, fixed rate bonds, that coupon rate is decided at issue and they stay the same. But the yield to maturity or the market interest rate does not stay the same. I mean, I'll give you the simplest example. Let's look at the 10-year US Treasury rate. Currently, it's 4.137, but over the last year, it has fluctuated quite a bit. It's kind of at a peak at the beginning of the year, and that was 4.78. But about a year ago, it was 3.80. Okay, for a lot of different reasons. We'll talk about how different things affect the market interest rates, but they do vary. Suppose, let's make this 10 years. And I'm going to make this 380. About a year ago, the yield to maturity on 10-year bonds, and let's make that semi-annual for 380. Okay, and bank coupon rate and yield to maturity are the same. Value of the bond is going to be exactly the same as the face value. In fact, we call such bonds par bonds. Okay. Now let's compare to what would have happened to the value of that bond at the beginning of the year. I'm going to call it 480. Okay. What do you think is going to happen to the value of the bond if the yield to maturity went from 380 to 480? Remember, that is the rate at which we're discounting cash flow from this bond. Is it going to go up or down? Remember, I'm discounting future cash flows at a higher rate. So should the value of the bond be lower or higher? Lower, because whatever you're going to get in the future is discounted more. So the coupon rate on this one is 4%, I think, or 380, which means each coupon is $19. The $19 that I'm going to get next year is discounted at a higher rate, so it's worth less. And this applies to all of them. Remember, in a fixed rate bond, coupons are fixed, they do not change. It's the market interest rate, how the market views does change quite a bit. I mean, this change took a while, so let's say this change happened overnight. So yield to maturity went up to 480. It was $10,000 before. It's now worth only 92.13. The price went down, and it went down quite a bit. And in fact, since I happen to know the original price, let's make this percentage. So price of the value of this bond went down by a little over 7.8%. That's pretty big. What if this was a 30-year bond? Again, starting with 380. When the coupon rate and yield to maturity are the same, the value of the bond is always equal to the par value, regardless of the time to maturity. So for a 30-year bond, you would have lost about 15.8% of the bond value. So this immediately tells us there's a price interest rate risk to the bonds. As interest rates fluctuate, the value of the bonds fluctuates. If the market interest rates go up, the value goes down. You may have actually heard or seen this in financial press. Interest rates and bond values are inversely related. Okay. This immediately tells us uh, interest rate risk of bonds is higher the longer is time to maturity. I mean, that kind of makes sense. In a 30-year bond, uh, when you go from 380 to 480, that's a big jump, and you're going to keep discounting at a higher and higher and higher rates. So that $1,000 you're going to get at the end is discounted at a really, really high rate, which means long-term bonds are riskier. In fact, one of the reasons we will talk about more in detail about that, but um, I don't know why this is like this. Okay, look at the 10-year rate, 414. Okay, but the 30-year rate is 471. So market actually attaches a higher interest rate to 30-year bonds. Among other things, one of the reasons there is such a thing, for example, 5-year rate is only 373. And normally in normal times, uh, the longer is the maturity of the bond, the higher is the market interest rate. Part of that is compensation for the interest rate risk. Because if I buy the 30-year bond, every 1% increase in yield is going to make me lose about 15% of my investment, right? On the other hand, if I buy the 10-year bond, that loss is only about half. So in order for me to take that risk, you're going to have to compensate me. That's kind of the idea. There are other reasons why that's the case. For example, if you did the same thing for the 5-year bonds, you would only lose about 4.4% or so, or one year bond less than percent. There is another component to uh, interest rate risk. Two bonds being the same, they may have a different coupon rate. Okay. Remember, coupon rates are decided by the issuer at the time of the issue. Certain issuers actually, uh, let's make this 380 for now. Let's make this 30-year, right? Oh, this is the so-called zero coupon bond or pure discount bond. The value of this bond is about 32, but you're going to twiddle your thumbs for 30 years. Then at the end of 30 years, it's going to give you $10,000. That's it. That's the only cash flow from the bond. And these are sometimes rather common, especially in corporate issues.